Hi everyone, this is Dr. Chiranjeevi Manike, Professor and Head of Data Science and Cybersecurity Department, MLR Institute of Technology, Hyderabad. As part of data mining video lectures, in this lecture we are going to discuss non-parametric methods. Those are used to store the reduced data under the category of data reduction. So in this lecture we are going to discuss mainly the non-parametric methods such as histograms, clustering, sampling, data cube, aggregation. So first let us understand what is a histogram and why we use histograms to represent this reduced form of data. So what are the histograms? A histogram is a graphical representation of data distributions. So it displays the frequency of data points within the specified intervals. Those are used to call as a bins or the buckets. So why we use the histograms for the data reduction? So mainly the histograms are used to simplify the data representation, that is for simplification purpose. So reducing the size of the data, and it also reduces the memory and the computational cost because the size of the data being reduced. So obviously the memory which is used to store the data and the computational cost also would be reduced. It also captures the data trends effectively, and this is very important one, because suppose let us say if we have a data set and that is converted into another reduced form, and this reduced data set should also represent the same trends. So that is very important to capture the data trends more effectively. And if you see the main components of a histogram, there are basically three components like bins or the buckets, then frequency, axes. So bins mainly used to define the range of values, like for example 0 to 10 and 10 to 20, and these are two different ranges. And these bins also determines the histogram granularity, level of details. So another component of histogram is a frequency, that is mainly used to count the data points in each bin. Next, third component is axes. Like if you take a simple example where the histograms are nothing but the rectangle shapes like this. So the x-axis denotes the intervals, like for example 0 to 10 is one interval, then 10 to 20 is another interval like this. Similarly, y-axis denotes the frequency. So let us see, because we need to understand before we plotting the data, that is before we visualize the data by using the histograms, we must understand how we can decide the bins, how the size of a bin would be decided. So there are basically two types of methods used in the binning. So one is binning which is based on the equal width. So another method is binning using the equal frequency. So in equal width binning, we'll divide the data range into the equal size intervals, like the just previous slide we have seen. The age or some values like or anything, it could be anything, some 0 to 10, so 11 to 20 like that. So this equal width binning will divide the range into the equal sized intervals. So whereas for example you can also see here in this the same example, so the prices and the count. So here this is a one interval 1 to 10, 11 to 20, 21 to 30, and 1 to 10 what is the frequency, and 11 to 20 what is the frequency, then similarly 21 to 30. So another method which is used for binning, that is based on the frequency, that is equal frequency binning. That means each bin contains approximately the same number of data points. So we'll see the next slide example so that we'll understand more about this methods of binning. So let us take one simple raw data set which has 10 data points, and this raw data set, this is the raw data set. So now we are going to apply like equal width binning and the frequency that we are discussed just now, like equal width binning and equal frequency binning. So let us try to understand this. So for example, if you consider this data set and if you follow this equal width binning, so let us take equal width binning. So here the first step we need to do is, let us say step 1, we have to find out the range. Suppose range of this data set, that is we find that is the difference between the max value minus min value. Okay, the difference between max and min, and here in this the maximum value in this data set is 18 and the minimum value is 1, so 17 is the range of this data set. So let us suppose next one, so we have to decide the number of bins. So number of bins, so let us say we want to divide the data into the 3 bins, right? So in that case, and this, the each bin size would be decided, that is each bin would have a total, that is the range divided by 3, and that is approximately some 5, and we can 5.67 like this, and we can round it to the 6 for simplicity. So then the bins, each bin, like bin 1, the range is 1 to 6, bin 2 range 7 to 12, and bin 3 the range is 13 to, let us say 18. Okay, so now the next step is we have to find out the frequency that is based on the data points. For example, if you consider the bin 1, then how many data points are within this range 1 to 6? So 1 to 6, how many? So there are these 4 data points are there, so the frequency would be 4. In second, bin 7 to 12, so again the second bin would contain 4 data points, and the third bin would contain the 2 data points. So this is the way we decide the bin size, and we'll divide the total data set into the bins, that is number of required bins. So let us also apply this another method, that is binning based on the equal frequency. Let me erase this part first. So now how we are going to divide this data set, that is to draw the histogram based on the equal frequency. Equal frequency. So in this case, so first we have to find out the number of data points in this given data set. So the total number of data points, so number of data points in this data set equal to 10. There are 10 data points in this data set. So then we'll divide, suppose if you want to create the 3 bins, so then the each bin is going to have, so we have to decide, we have to check, we have to find out the number of data points each bin is going to have. So that is, we can decide based on this the total number of data points, that is 10 by 3. So that value is 3 to 4 data points approximately. Each bin is going to have the 3 to 4 data points. So data points. So now, so let us divide the data set into the 3 equal bins based on the that is binning based on the equal frequency. So in this case, like let us say the first bin, so we can keep 3 to 4 data points in each bin, but before that we need to sort this data set, sort this, and then distribute among the bins. So now, so bin 1 is going to have, because we have to keep 3 to 4 data points in each bin, so let us first take the 4 data points. So then 1, 2, 3, 6, and second bin B2, and let us take 3 data points. So then remaining 3, 7, 8, 10, and then B3 third bin is going to have 12, 14, 8. So then the each bin, the frequency would be calculated. Frequency, so that is equal to, like in this case, the bin 1 has 4 data points and 3 data points, in this 3 data points. So these are the methods we use to decide the bins, that is equal width based on equal width and based on the equal frequency. And this is one simple example to understand, and this is a data point, data set given. So, and this is a histogram which represents this data set, and this histogram here, the values represents the prices, and this is called as a singleton bucket or bins, because the each bucket represents one price value. So this is a singleton bucket. Similarly, and this is another histogram for the same data set, where the bins are decided based on the equal width. So here you can see the equal width histogram for the price, where the values are aggregated so that each bucket has a uniform width of 10. The 10 is the width of each bucket. And this is another simple example to understand, like suppose if you would measure the height of students in a classroom, right? So if you plot the frequency and the height, that is in centimeters, then we would be able to see the histogram like this. So here you can see the first this one represents the two people from, that is 140 to 145 centimeters range. The next histogram, next one, the bar represents the 5 people, that is 5 people. Those are their height is 145 to 150 centimeters. Similarly for the rest. And how the shape of a histogram would be. The shape or the shapes of histograms would be mainly based on the data distribution. So, and this is in this figure it represents mainly the normal distribution, and this is a bell-shaped curve. You can see the data distribution is 100% symmetry. So here 68%, 68, 95 and 99.7. This is also called as a 68, 95, 99.7 rule. So we can easily understand, and this is the mean and this is the standard deviation. The data distribution is explained based on the mean and the standard deviation here. So here the 68.27, that means this is the range. That means, so the 68.27% of the data is one standard deviation away from the mean. And whereas this limit, that means the data within this range, that is the data that is 95.4% of data is two standard deviations away from the mean. And similarly, the 99.73, that means that 99.70% of the data is three standard deviations away from the mean. So how the frequencies, so how the shape of the histogram would be affected based on this mean, median and mode. So we'll see whether it is left skewed, right skewed based on the mean, median and mode. And this is a figure which depicts the different shapes of the histogram. Like a symmetric, you can see it is almost like the previous bell shape. If you divide this into two halves, and the right and the left both are equally symmetric, where the mean, median and mode values are same for this point. And whereas the right skewed or the positive skewed, so you could see there is a long tail on the right side. So this is called as a right skewed or the positive skewed. Whereas another one, here you can see the relationship between the mean, median and the mode, the measures of central tendency. So here you can see the mode value, median and the mean. And similarly, the left skewed, there is a long tail on the left. This is also called as a negative skewed, and the corresponding relationship between the mean, median and mode. So that means based on this relationship, the mean, median relationship, we understand whether the data set is skewed. That means whether positively skewed or negative skewed, or whether it is symmetric. So what are the challenges mainly in this histogram data retention? Mainly the first challenge is selecting the bins. That is, if you select the very few bins, then we would lose the more details. Even if you select the many bins also, too many bins also, and that would become a redundant and more noisy. And another challenge is the data sensitivity due to the outliers and this skewness. These two affect the binning. That means if our data set has outliers, if our data has a skewness, then that would affect the binning. So these are the two main challenges in histogram. So the next method, non-parametric method in data reduction, is clustering. So clustering means that is grouping the objects into the grouping the objects based on the similarity. So here mainly we'll group the objects in the data from the data set into the clusters based on the tuples or the objects. So this cluster partitions the objects into the groups. Those are called as clusters. So that objects within the cluster, and these are the objects. Let us say this is one cluster and this is another cluster, like this. So objects within the cluster, these are all the different objects within the cluster. Those are similar to one another, and the objects in the another cluster, like suppose these are, which are dissimilar to this one. Okay, so within this cluster, objects are more similar, whereas from one cluster to another cluster, the object similarity is very less. For example, let us take the student scores. So how we can do this clustering based on their scores. And this is the data, this is a sample data we have, like students like A to H, and the two subject scores, maths and English. Our goal here is to group these students into the clusters based on their similarity in the scores. So here we'll follow. We are not going to discuss in detail of the clustering, like mainly one basic clustering technique we are going to use. I'm going to use here to explain this simple example. K means clustering. K means is the number of clusters. So here in this case, first how we are going to divide, we are going to start, and how we'll make this these data points into the different clusters. First we have to decide the number of clusters. Like we have these many students, and how many groups you want to make these students into. So that need to be decided. So suppose let us say the K value, that is the number of clusters, is 2. Just that means we want to group the students into the 2 clusters. So those you can rename as like a high achievers and low achievers. So the first step we randomly choose, that is as an initial step, we'll choose the 2 centroids. Centroids are nothing but the cluster heads. For example, C1 and C2. And this C1 is 8578. 8578. This is the one cluster we randomly selected, and C2 is a 5552. And this is another cluster we randomly selected. So then we follow the next step. That is the second step. That is we have to assign the data points to the nearest cluster. That means, so like these are the clusters randomly we have selected. We have to find out the distance. Nearest in the sense we will measure the distance. We use the distance measures like Euclidean distances to measure the similarity or the distance, how far the data point is from the cluster. Okay, so like suppose each data point, like these are all the data points. Each tuple represents a data point. So each data point we have to find out the distance to the cluster, either C1 and C2. Both clusters we have to find out the distance. For example, if you take 85, the first data point, that is student A, and the max score is 85. So first step, we have decided the number of cluster, then we randomly selected the 2 cluster, that is C1 and C2. Then the second step, we have to assign the data points to the nearest cluster. So we have to find out the distance from the cluster and then the data point. So we can decide which are the data points near to the cluster. So here we to find out the distance. So we use a Euclidean or some other distance methods to calculate the distance. So for example, if you take the data point A, 85 and 78, and these are the values, scores in math and English, and the distance to the C1, because like suppose here, let us say we use this Euclidean distance like x2 minus x1 whole square plus y2 minus y1 whole square. So in this case, like if you apply this formula, so we find out the distance between these values like x1 y1 and x2 y2. Let us say these are the x2 y2. So then if you apply this distance formula, then we'll find the distance, because both the data points then x1 x2 and both are similar, so that will be equal to 0. And the distance to the another cluster, next cluster, 55 and 52, and that is like 42.43. So, and this data point is close, the distance is 0, so that means it is very close to the cluster C1. So that's why we assign the cluster C1. Similarly, you can take another example also, like 60 and 58. And 60 and 58 will find the distance to the cluster C1 and also the cluster C2. And if you compare the distances, and 6.71 is the very small, so it is very close, so that we'll assign this data point to the cluster C2. So this is the way we assign the clusters, that is each student to the nearest cluster. So then the next step is we need to update the centroids or the cluster heads. So once the data points are divided into the clusters, and we'll update the centroids, that is by finding the average, the mean value of all the data points in a particular cluster. So that mean value would be the value of the new cluster in this case, and this is the C1's new cluster head, and this is the C2's new cluster head. Next, we have to repeat, that is the same process, that is again once we calculate the cluster heads, and we'll again assign the points based on the updated centroids. We'll find out the distance and again we'll assign the data points. So then again next to update the centroids. So this process will be continued until no change. Okay, so that means the previous step. So previous step and the present step, both the centers, cluster centers or the centroids remains the same, so that we can stop this clustering. So the final results would be like here the C1, C2. So this first cluster belongs to A, B and F, and second cluster the students are belongs these following students like C, D, E, G, H are belongs to the second cluster. So we can interpret these results like cluster 1 like high achievers, because if you go back to their scores, then we would find that the students with the highest scores in the math and English will belongs to the clusters 1, and whereas the low achievers, the students with relatively low scores, belongs to the second cluster. And how do we measure the quality? That is another very important in clustering. So the quality of a cluster may be represented by its diameter, that is the maximum distance between any two objects in the cluster. So centroid distance is another alternative measure of cluster quality, and it is defined as the average distance of each cluster object from the cluster centroid. So that denotes the average object or average point in a space for the cluster. Let us take one real-time example. So here the example is the customer segmentation for e-commerce. The scenario is an e-commerce company wants to group its customers based on their behavior for personalized marketing campaigns. So let us take a data set here. So in this data set, each customer is described by the three features, mainly the total amount they spent, a number of purchases, and the time spent on website. And this is a sample data, like a customer given the customer ID and the total amount to spend and number of purchases and time spent on website. So if you apply this k-means clustering or any other clustering approach, then we'll get the result, that is the data point. The customers would be divided into the clusters. Like suppose if you divide those customers into the three groups, then the first group, that is high spenders, because you can see this the amount. So the customers who spend a lot and they also visit the website frequently. So what action need to be taken here? So we send the premium offers or the loyalty rewards. That is action we'll take. And second, the cluster we can see that moderators spenders. So where the customers with average spending habits. So what action could be taken against this segment? So we could provide a personalized discounts to encourage the more purchases. And similarly, let us go to another third cluster, like where the low spenders. So in this case, the customers with the minimum activity. So what actions need to be taken in order to improve the sales? So we could run the re-engagement campaigns like free shipping or the first purchase discounts, etc., to attract a more number of customers. So if you could summarize what we had discussed in this lecture. So we discussed mainly the two important techniques in representing the reduced form of the data, that is mainly the histograms and clustering. Histograms are highly effective, that is approximating both sparse and dense data, as well as highly skewed and uniform data. The single attributes, we have seen one simple example, but those attributes can also be extended for the multiple attributes also. So multi-dimensional histograms can capture the dependencies between the attributes, because more number of features attributes would be considered. And these histograms have been found effective in approximating the data with up to the 5 attributes, these multidimensional attributes. So singleton buckets, that means it represents only the one attribute, are useful for storing the high frequency outliers. So another method that we discussed in this is a clustering. That is one of the more effective way to reduce the data set. Like we have discussed the two examples, like clustering the students based on their scores and 2 subjects, and similarly the another example like a customer spending habits. So we divide the clusters. So that's it. Thank you for watching this.